Now let's get started with the Android Studio IDE. Let me get it started here, and you will see on the splash screen that this is powered by IntelliJ. The IntelliJ IDE comes from a company called JetBrains. JetBrains has worked very closely with Google in order to make an IDE that is specifically designed to be effective for Android development. Here we have the welcome page in Android Studio and the ability to start a new Android project or open an existing one, import one of the Android code samples. One of the things we'll see in a moment when I start up the SDK Manager is that the SDK comes with many sample projects, and you can simply select one and import it into the IDE this way. We can check out projects from version control. The IDE supports a wide range of version control mechanisms, of course including Git and SVN. You can import a project from Eclipse ADT, from the Eclipse Android Developer Tools, or as a Gradle project. Many times I have imported an existing Eclipse ADT-based project into Android Studio, and I would say in almost every case, again, I don't want to make a sweeping statement on this, but in almost every case it is imported very cleanly without any problems whatsoever. Now that's a one-way import, by the way. As we'll see, the project structure changed between Eclipse and Android Studio, so that once I've imported it into Android Studio, I'm not going back to Eclipse on this. There's a configure section and a section on docs and how-tos, but I'm not concerned with that right now. What I'm going to click first is Start a New Android Studio Project. This brings up the new project wizard. You can see here that they present us with an application name that defaulted to My Application, and then a company domain and a package name and a project location. Now, the application name is important. That's the name that you're going to care about when we're talking about deploying it to Google Play. But here it doesn't really matter too much. I'm going to call this Hello Android, and to distinguish it from all the other Hello Androids I've done in the past, I'll even call it O'Reilly at the end, just to make it clear where this is coming from. Now the company domain I currently have here as the last one that I've used. I'm going to change again to O'Reilly.com. What is done with the company domain is that the root package of your application uses that company domain in a reversed URL followed by the application name. Now, if I put spaces in the application name, Hello Android O'Reilly, I can even put in a quote, you'll notice that all of those are taken out and everything is made lowercase when building the package name. If you're a Java developer, and I assume you have some background in Java, this is quite familiar. But this is actually more significant than it is in a Java project. You see, the package name here, internal to the Android application, is going to be known as the application ID. And every application ID deployed to the Google Play Store must be unique. Now, they don't have a mechanism for enforcing uniqueness unless you have a conflict. But by using the reverse URL, you are very likely to avoid any potential conflicts. This package name or application ID is not exposed to the customer. You don't have to worry about that. But it is used internally within the Google Play Store. Also, every application that you make from your company should have that same basic package name, although they'll obviously have different application names themselves. But that combination of application ID with the package name, the company domain and the application name is used to help distinguish applications within the Play Store. So I'm going to call my application Hello Android O'Reilly. There's my package name, com.o'reilly.hello Android O'Reilly, and I'm going to click Next at this point. Target Android devices. Select the form factors your app will run on. Different platforms may require separate SDKs. You can see that the basic idea is to run on phone and tablet. Back when Honeycomb came out, there was quite a distinction between phones and tablets because phones at the time were very small and tablets were, relatively speaking, quite large. That distinction has become less important over time. Now, many phones have particularly large screens, and tablets have a range of sizes, some of which aren't all that much bigger than phones. So anything that was originally designed for tablets works pretty well on phones even now. Certainly, we're going to use phone and tablet. Now, the other options down here are on Android Wear devices, which are already in circulation and should be getting better over time. There's something here for Android TV as well, which is available but not that common. And then Android Auto, which again is set for a very large amount of growth in the next couple of years, but probably not that critical right at the moment. And finally, Google Glass, which I'd say you probably cannot worry about at this point. Now, when you choose the phone and tablet, you see there's a minimum SDK level. And here you'll see all three of those measures, the API number, the version number, and the dessert. And when you click on the drop-down, you can see they have everything going all the way back to Android 1.0, 1.1, then API level 3 jumps to Cupcake and Donut and Eclair and on and on and on. And that the last one, the one I have installed now, is MNC, which in my mind lends a lot of evidence to that whole macadamia nut cookie idea. But again, we'll have to wait and see which one they actually choose. Here I have chosen API level 15 as my minimum SDK. That's not the SDK I'm restricting myself to. That's the SDK that I'm choosing as my minimum, saying that I am willing to support any device that is on that SDK or higher, 15 or higher. When you deploy to the Google Play Store, if somebody accesses the Google Play Store with a device below 15, they will not see my application. And if they get there through a direct link, Google Play will say none of your devices support this application, or something to words to that effect. Again, as we've seen, that's not much of a restriction. Right now, the evidence is roughly correct that approximately 94% of all apps will be supported by this API level. I'm not going to worry about the others. I'm going to stick with the phone and tablet and click Next. At this point, they offer to add an activity to your application. Now, it's possible you can add no activities, but we're going to add a blank one. Activities, again, represent a single screen on an Android application. They offer to make a blank one, or something we'll look at later, blank activity with a fragment. Here's the option to make a full screen activity. It's still a regular activity, but has additional code in it that can go full screen if you want. Google AdMobs adds some extra dependencies in case you want to work with their ad platform. Here's a navigation drawer activity, which is an appallingly large amount of code, but does do the job. Master detail flow is where fragments really come into the fore. Login activity, Google Play services, a Google Maps activity, again, will add an additional library dependency, a settings activity, which I am going to demonstrate later, and a tabbed activity. So each version of Android Studio that comes out is slightly different. It's still an actively developed platform, and sometimes you'll see it at this stage where they show new kinds of activities you hadn't seen before. I'm going to go with the blank one, again, trying to keep things as simple and straightforward as possible. Now I'll click Next, and it shows me that this is supposed to be, as it says here, creating a new blank activity with an action bar. This black bar along the top is known as the action bar. There is a class called action bar added in the Honeycomb API that we will be using later on. The action bar has an icon to represent the application itself, a title. This little caret here is like a back button. It basically allows you to go to a previous activity, which we'll see later. And then there's a drop-down list for the menu. Inside we have blank. Activity name defaults to the name main activity, which is fine for our point of view, not a problem there. And then there's a layout name, which is the same thing except lowercase and reversed, activity underscore main. This, believe it or not, is going to be an XML file. Our initial layout for an activity will be written in XML. Now, if I modify the name of the activity, like I call it my main activity, notice how it changed to activity underscore my underscore main. So it isn't truly reversed, but it does try to keep the name of the activity in sync with the name of the layout file. I'm going to take that my out just to keep it simple again. The title doesn't matter, and then finally there's a menu resource name. Resources are these XML files called menu_main, and I'm willing to live with all of those defaults. So now I'm going to click Finish. What's happening now is that the application is generating a Gradle build file, downloading all the required dependencies. Of course, mine are already cached, so it's not like it needs to go off-site or anything like that. Building the standard project structure and starting up the application. I mentioned while we're waiting that Eclipse basically focused on an IDE build, is that everything was done through the IDE. It's not that Android Studio doesn't do the same. It is still doing an IDE build, but there is a fundamental difference. And the fundamental difference is that in Android Studio, it's actually driving the Gradle build. So everything we do within Android Studio is something that you could do equivalently at the command line using the Gradle command. Our application has now come up, and in the next video, I want to walk through all the different pieces of it. I want to add a few widgets to our Hello World application. I want to start looking at the Java code, and then I want to deploy this application using an emulator.